Hello everybody, welcome into another lesson. So today we are going to talk about solving two variable linear equation systems using matrices. So today's lesson we will focus on solving just two variable systems, which would result in two equations, like the normal systems of equations that you see with two variables. We are going to use matrices for those. Now, to use a matrix to solve a linear system, a system of equations in two variables, you have here this system, ax plus by equals c, mx plus ny equals d. The a, b, m, and n are your coefficients on the x and y variables like you would see in a normal two variable system of equations. The c and d are, of course, the constants that those two equations are equal to. What you're going to do to use a matrix to solve the system is you're going to set up a 2 by 2 matrix here. You're going to, since you have two equations with two variables, it would be a 2 by 2 matrix. So you would take the coefficient of your first x variable, make that the top left term, take the coefficient of your first y variable, make that your top right term, and then you're going to draw a little dotted line here. That dotted line turns this into what is called an augmented matrix. An augmented matrix will show you what the right side is equal to. So to the right of that divide, you'll put what the top equation is equal to. And then for the second row, you'll put the coefficient on the x variable, then the coefficient on the y variable. Then to the right of the dividing line, you'll put what the bottom equation is equal to. An augmented matrix does not change the dimensions of your matrix. Everything to the right of the divide is not considered part of your dimensions, only what's on the left. You would have a 2 by 2 matrix that's augmented with the solution to each equation. So that's an augmented matrix. We are going to use what is called Gauss-Jordan Elimination with back substitution. And believe it or not, we've already been doing this when we were solving systems of equations. We did this when we were just doing the elimination method with systems of equations without turning them into matrices, back when we were solving them the normal way. The idea of Gauss-Jordan elimination with back substitution is you're going to do some elementary row operations, much like we did before when we left the equations in the normal form without turning them into a matrix, and we did elimination method. The idea is we're going to get this into what is called row echelon form. Now there is a reduced row echelon form which we will talk about in the next lesson. But the general row echelon form is different than reduced row echelon form. All you need to worry about for today's lesson is the regular row echelon form. So the leading digit in both of your rows has to be a 1, okay? So in the first row, the leading digit will always be a 1. And then you could have whatever coefficient you want for the second term, and then whatever value that equals on the right side of the divide. Okay, but the first term should always be 1 in the first row of the matrix. Now in the second row, the very first term should always be 0. It'll always be 0 for your second term. And then the next digit to the 0 to the right of it is called your leading digit. That leading digit must always be 1, called a leading 1. This is called a leading 1. So the second number in the second row will always have to be a positive 1. The number to the left of that would always be 0. What this does in the second row, that 1 becomes the coefficient for your y variable. That would tell you that y equals c. And then you're going to take back substitution, put that into the top row, So you would have literally a times x, a times y in the first row. You'd put in that c for the y value, and then you would just solve for x. So it's much like what we did with normal systems of equations. If you have any other number besides 1 as your leading digits in either of the rows, it is not in row echelon form. And your very first number of the second row, if it's any number besides 0, it's not in row echelon form. So that's something to take note of. Now we are going to do 3x3 equations in a separate lesson, but I think today we're going to stick with 2x2s. Now, let's see here. I have our first system here, 6x plus 4y is equal to 8. Then I have 3x plus 3y is equal to 9, okay? So what I can do now is I can take this system of equations, put it into an augmented matrix. This will be a 2x2 system that's augmented. So I'm going to take the coefficient of my x variable for the first row, for the first equation, which would be 6, then take the coefficient for the y variable, which would be 4, put that as my second term of the first row, then draw a dotted line which would turn this into an augmented matrix and put the 8 to the right of that for what this equation is equal to. Now, to form my second row of the matrix, I'm going to take the coefficient of the x variable of that equation, which is 3, and then I am going to take the coefficient of the y variable, which is also 3, and then I am going to take my 9, put that to the right of the divide. What we have here now is the augmented matrix that represents this system. So where do we go from there? Our very first goal should be to make the first number in the second row 0. That's the very first thing we should do. How am I going to do that? With Gauss-Jordan elimination, which we've actually been doing all along. Now we're just doing this in matrix form. If I take row 1 plus the negative of row 2, which would be minus 2 times row 2, right? So if I basically 6 minus 2 times 3, that would be 6 minus 6. That's going to turn this first term into 0. So write down your row operation beside the matrix, row 1 minus 2 times row 2. Draw yourself an arrow and then move over on your paper and perform the row operation. When you do that, your first row stays the same for a minute. You'll have 6, 4, and then to the right of the augmented line, 8. Now this is where we perform the elementary row operations. Take your row 1 minus 2 times row 2. So 6 plus negative 2 times 3, that'd be 6 minus 6, which is 0. You end up having a 0 entry in your second row. Now, if I take row 1 for the second term, which would be 4 minus 2 times 3, that would be 4 minus 6. Well, that would turn into negative 2, which then is going to give me the negative 2. And then if I take row 1, which is 8 minus 2 times 9, 8 minus 2 times 9, that's 8 minus 18, that'd be negative 10. So what we've done now is we've made the second row have a 0 where the x is. We have a value for y, but it's not yet in row echelon form. Why is that? That's because we need to go ahead and take the second row and divide that by negative 2. So if I take negative 1/2 times row 2, that'll get a leading 1 in the second row, okay? So take negative 1/2 times row 2. Row 1 gets left alone for now. You'll have 6, 4, and 8 still in the first row. But negative 1/2 of row 2, well, negative 1/2 of 0 is still 0. Negative 1/2 times negative 2 is positive 1. Negative 1/2 of negative 10 is positive 5. Now I've got a leading 1 in the second row. We're almost to row echelon form, but we're not there yet. What I need to do now is make the coefficient in the first row a 1. So, what I need to do now is go ahead and divide the top row by 6. So I'm going to take 1/6 of row 1. Let's come over here. What is 1/6 of row 1? 1/6 of 6 is 1. 1/6 of 4 is 2/3. 1/6 of 8 would be 4/3. And then you just leave row 2 alone. That would be 0, 1, and 5. Now we have a matrix in row echelon form because both rows have a leading 1. Now let's go ahead here and solve for y. That 1 coefficient in the second row means that's a 1y. And then on the right side, that's a solution to y. So that means your y equals 5. Now we're going to take that value of y, put it into the top equation. The top equation will literally become, so we got y, right? The top equation will become x plus 2/3 y equals 4/3. Well, this is where the back substitution comes into play. Just go ahead, take your y value of 5, put that in for where the y is, so you'll get x plus 2/3 times 5 equals 4/3, which would give you x plus 10/3 equals 4/3, which would end up giving you x equals negative 6/3, which means x equals negative 2. So now the ordered pair that's your solution for this matrix is going to be negative 2, 5. And if you doubt that, put that into any of the original equations. You would actually end up getting a true statement in each case. So the ordered pair that's the solution for this system is negative 2, 5. So what we've done is we converted our system of equations into an augmented matrix. We did some elementary row operations to get this matrix into row echelon form, which means you have a leading 1 in both rows. And then we used back substitution when we found the y value, put it into the first one, into the first equation, and we found our ordered pair that's going to be our solution set. And I got some more. I do have more. Alright, so what is the next system? We have x plus y equals 2. Then we have 7x plus 8y is equal to 21. So we have the system x plus y equals 2, 7x plus 8y equals 21. First thing, convert this into a matrix. So you're going to have 2 rows here since there's 2 equations. Your first term will be the coefficient on the first x variable, which would be 1. The second term of your first row will be the coefficient on the y variable, which is also 1. And then, of course, to the right of the augmented line, you'll put the solution to x plus y, which is 2. Now for your second row, you'll take the coefficient on the x variable, which is 7. Then take the coefficient on your y variable, which is 8, and then to the right of the augmented line, take what this equation's equal to and put 21. Well, let's look at this here. The top row would already be in row echelon form, but the whole matrix still isn't because you don't have a 0 for the first term of the second row, and you don't have a leading 1 in the second row, but we're almost there. So basically, we don't need to mess with row 1 since we have a leading 1. That's going to make our life a lot easier. But first thing you want to do is go ahead, get rid of that 7. You need to turn that 7 into a 0 in the second row. That needs to become 0. So in order to do that, we're going to take -7 times row 1, plus we're going to add that to row 2. So let's form our resulting matrix. So you're going to leave row 1 alone. That'll be 1, 1, and 2. Now, -7 times 1 is what? -7 plus 7 is 0. Alright, -7, so -7 times 1 is -7 plus 8 is 1. And then -7 times 2 is -14. Plus 21, that would be 7. Well, what do you know? This actually worked out. We don't have to do anything further. We already got this into row echelon form now, because we have a 0 for the first term of the second row, and we have a leading 1 for the first digit of the second row. So that 1 and 7 there tells you that y equals 7. That's really going to help you. Since y equals 7, now we can use back substitution and put it into the first row. So this here is saying that literally x plus y equals 2. Take that 7 as your y for the value of the y variable, put that in here. You'll get x plus 7 equals 2, which would give you x equals -5. So the ordered pair that's going to be your solution would be -5, 7. So -5, 7 is the solution to this particular system of equations. And again, when in doubt, you can always stick them into either of these two equations. You should get a true statement every single time for both sides. That one actually wasn't terrible. All right, let's do the next one. So we have x plus 2y equals -9. Then we have -2x minus 3y equals 14. All right, so x plus 2y equals -9. The -2x minus 3y equals 14. Let's convert this into an augmented matrix first. So in the first row, take the coefficient on your x variable, which would be 1. Then take the coefficient on your y variable, which would be 2. And then form your augmented line. And then put what that equation's equal to on the right side, which would be -9. Now for your second row, go ahead, take the coefficient of the x variable, which would be -2. Take the coefficient of your y variable, which would be -3. And then take what that equation's equal to, put it on the right side, which would be 14. Alright, so now we have our 2x2 augmented matrix. Well, the first row has a leading 1, once again, so we can leave the first row alone altogether. That's going to make our life so much easier. However, the second row, we definitely need to get rid of that -2 and make the first entry in the second row a 0 in order to make this into row echelon form. So, how are we going to do that? If you take 2 times row 1 and add it to row 2, you can certainly do that. So let's go ahead and do just that here. So keep your first equation the same. You'll have 1, 2, -9. -2, -3, and then 14. Whoops, I'm sorry. We're doing the row operations. You're not going to have that. I ended up rewriting the original matrix, which I didn't want to do. There's no point in that. So 2 times row 1. All right, so 2 times 1 is 2, plus -2 is 0. So now we got our desired 0 entry. Now, go ahead, take 2 times 2 in the first row, which is 4, plus -3 would be 1. And then take 2 times -9 in the first row, which would be -18, plus 14, that'd be -4. And what do you know? Your matrix is now in row echelon form. Both rows have a leading 1, and the first entry in the second row is 0. It's in row echelon form. So that 1 and then the -4 literally denotes that y equals -4. Now you're going to stick that y value, use back substitution into your first equation, which would tell you that x plus 2y equals -9, which now will put that y value of -4 in. So you'll take x plus 2 times -4, set that equal to -9, which would give you x minus 8 equals -9, which would give you that x equals -1. So the ordered pair that would be the solution for the system would be -1, -4. So -1, -4 is the ordered pair that is the solution for this system of equations. Okay. I still have about 6 more, but I want to take time and teach this right. So I have for the next one, x minus 3y is equal to 5. And then we're going to do -2x minus 4y is equal to 20. Alright, so we got this system here. We have x minus 3y equals 5, -2x minus 4y equals 20. So first thing again, set up your augmented matrix. So it's going to have 2 rows since there's 2 equations. So take the coefficient of your x variable, that'd be 1. Then take the coefficient of your y variable, that'd be -3. Then draw your augmentation line. Then put the number that's to the right side of the equal sign on the right side of the augmentation sign, which would be 5. Now, go ahead and take in the second row, take the coefficient of your x variable, which would be -2. Then take the coefficient of your y variable, which would be -4. Then put the number that it's equal to on the right side of the augmented line, which would be 20. Alright, so now we have set up our matrix. So the first row already has a leading 1. That's going to make life a lot easier for us. But it's the second row where we need to start out by getting rid of that -2 and turning the first entry into a 0. So in order to do that, we could take 2 times row 1, add that to row 2. So take 2 times row 1 plus row 2. Then let's form our new matrix over here. Keep your first row the same since we're not changing that. That one's already good to go since it has a leading 1. Now, 2 times 1 is 2, plus -2 is 0. Now then, 2 times -3 is -6, plus -4, that would turn into -10. And then 2 times 5 is 10, plus 20, that actually turns into 30. Well, we got one step down. We have the first entry of the second row as a 0, but this is still not in row echelon form yet. The reason being is because the leading digit is not a 1. In order to do that, we need to take -1/10 of the second row to turn this leading digit into a positive 1. So take -1/10 of row 2, form your matrix from that, you're still going to leave the first row alone, which would be 1, -3, and then 5. Now, -1/10 of 0 is still 0. -1/10 of -10 turns into +1. -1/10 of 30 would be -3. So we now have this in row echelon form since the leading digit in each row is 1. Now this is telling us that y equals -3. So we got y equals -3. Okay? So we can use back substitution now to put it into the top equation, which this is literally telling you that x minus 3y equals 5. So put that y value in, you'll get x minus 3 times -3 is equal to 5, which would give you x plus 9 equals 5, which would give you an x value of -4. So the solution to this system is the ordered pair -4, -3. That would be the ordered pair that's the solution, is -4, -3. All right, let's go on to the next problem. We have 3x plus 2y is equal to 2. And then we have 5x minus 6y is equal to 50. Big jump in the second one. So we have 3x plus 2y equals 2. Then we have 5x minus 6y equals 50. Well, go ahead and set up your matrix first. Set up your augmented matrix. You'll have 2 rows since you have 2 equations. So take the coefficient of the x variable in the first row, which would be 3. Then take the coefficient of the y variable in the first row, which would be 2. Then form your augmentation line. You'll put the 2 on the right-hand side for what it's equal to. Now, to form your second row, take the coefficient on your x variable, which would be 5. Then, go ahead and take the coefficient on the y variable in the second row, which would be -6. Then, on the right side, you'll put that 50. Alright, so here is your augmented matrix. You have 3, 2, 2, 5, -6, 50. That represents this system of equations. Now, bad news is we don't have a 1 to work with this time in the first row. Well, here's what I'm going to recommend. Don't convert it to a 1 just yet. Don't do any division yet and make that a 1, because if you do, you're going to have fractions to work with out the wazoo. What I am going to suggest to you is this. What if we took, because first thing I would recommend, always make that first term in your second row a 0 before you even make the first term in your first row 1. Make that first term in your second row a 0. Always do that. If you take -5 times 3, you would get -15. And if you take +3 times 5, you would get 15. You can add those together and then make the second, in the second row, the first entry be a 0. So we're going to take -5 times row 1 plus 3 times row 2, and then we're going to see what happens. So for now, keep your first row the same. We haven't touched it yet. Now, for purposes of adding here, if I take -5 times row 1 for the first digit, so -5 times 3 is what? -15 plus 3 times 5 would be +15. That turns my first digit into a 0. Then, if I take -5 times that 2, that's going to be -10 plus 3 times that negative 6, that'd be negative 10 minus 18. That'd become negative 28. And then this is where it gets fun. If I take negative 5 times 2, I get negative 10 plus 3 times 50. So negative 10 plus 150 would be 140. So yowzer, we got a real fun one here. We have this. We do have a 0 in the second row for our first term, but the leading digit's negative 28. That's still not in row echelon form. We need to make that leading digit a 1. So we got to take negative 1/28 of row 2. Take negative 1/28 times row 2. You should get this matrix. You're still going to leave your first row alone, at least for a moment. 3, 2, and 2. Then negative 1/28 of 0, well, that's 0. Negative 1/28 of negative 28 is positive 1. I believe, yes, this does actually. Now, 28 and 140 divide evenly. Negative 1/28 of 40 would end, of 140 rather, would end up being negative 5. So now we have a leading 1 in the second row, but we're still not done. Not at all. We need to make the first digit in the first row a 1. In order to do that, you're going to take a third of row 1. That's all you're going to do. Divide the first row by 3. Let's get your new matrix here. A third of row 1, excuse me. So a third of 3 is 1. A third of 2, well, that's 2/3. And then the same on the right side. A third of 2 is 2/3. And then you leave your second row alone, you'll have 0, 1, and negative 5. Well, what do you know? You now have it in row echelon form. The leading digit in each row is a 1. This is telling you that y equals negative 5, so we're good there. Y equals negative 5. We found that solution. Now we're going to use back substitution. So you're going to put that into your top row. This is telling you that x plus 2/3 y equals 2/3. So put that negative 5 in for your y, you'll get x plus 2/3 times negative 5 would end up equaling 2/3, which this will turn into x minus 10/3 equals 2/3. This would just give you that x equals 12/3, which means x equals 4. So now we have the ordered pair that's our solution. It's going to be 4, negative 5. So the ordered pair that becomes our solution is going to be 4, negative 5. All right, next system. We have 4 more. Yep, all right, so we have x plus y equals negative 1. Then we have 7x plus 9y is equal to negative 19. So we have the system x plus y equals negative 1, 7x plus 9y equals 19. Well, let's turn this into an augmented matrix first. So we'll take in the first row, we'll take the coefficient of our x variable, which is 1, then take the coefficient of your y variable, which is also 1, then draw your line of augmentation. You would put that negative 1 to the right of that line of augmentation. Now, to form your second row, take the coefficient on that x variable, which would be 7, then take the coefficient on your y variable, which is 9, and then put that negative 19 to the right of the augmentation line. You've just formed your augmented matrix for this system. This time, the leading digit in the first row is a 1, so we can leave the first row alone entirely. That's going to make life a lot easier. But we need to make the first digit in the second row become a 0. If we take negative 7 times row 1 and add that to row 2, we'll end up making that happen. So let's form our new matrix here. So you'll still have 1, 1, and then negative 1 in your top row, but negative 7 plus 7 is 0. Now, negative 7 plus 9 is 2, and then negative 7 times negative 1 is positive 7, plus negative 19, that becomes negative 12. Well, we got the first digit in the second row to be 0, but this is still not in row echelon form yet, because your leading digit's a 2 and not a 1. So we need to take half of row 2, and we'll form a new matrix. So take half of row 2, and then this will turn us into row echelon form. You'll leave the first row alone, and it's still going to be 1, 1, negative 1, but half of 0 is still 0, half of 2 is 1, half of negative 12 is negative 6. Now we have this in row echelon form, so that's telling us that y equals negative 6. So y is equal to negative 6, okay? Then we can just use back substitution, put it into the top equation, which tells us here that x plus y equals negative 1. So take x plus negative 6, which equals negative 1. We'll add 6 to both sides, which would give you that x equals 5. So the solution, the ordered pair to this, that's the solution to this system, is going to be 5, negative 6. That's the ordered pair that would be the solution, is 5, negative 6. I got just 3 more, then we're done for the day. All right, now we have here negative 2x minus y is equal to negative 5. We have 6x plus 5y is equal to 17. Okay. So let's go ahead and form our augmented matrix here. So if I do that, the first row, I'll have the coefficient of my x variable, which is negative 2. Then the coefficient of my y variable, which is negative 1. Then to the right of that line of augmentation, I'll put the negative 5. All right, so now I'm going to do my second row. The coefficient of the x variable is 6. Coefficient of the y variable is 5. Then I'll put that 17 to the right of the line of augmentation. All right, so there's my augmented matrix. Well, I don't have a 1 this time in the first row. That's okay. We're not going to focus on that for a minute. We're going to focus on getting the first number in the second row to become 0. If I take 3 times row 1 and add it to row 2, I can do that. So take 3 times row 1 plus row 2, I'll be able to make my first digit in the second row 0. So for a minute, leave your first row alone of negative 2, negative 1, negative 5. Now, take 3 times that negative 2, which is negative 6, plus that 6, well, that's 0. Take 3 times that negative 1, which would be negative 3, plus your 5, that would be positive 2. Then take 3 times negative 15, so 3 times negative 5, excuse me, which would give you negative 15. plus a 17, which would give you positive 2. All right, well, for one thing, it's great that we got a 0 as the first number in the second row, but it's still not in row echelon form because the leading digit's a 2 and it's not a 1. So I would start with taking half of row 2. If you do half of row 2, you should get the leading digit to become a 1. So keep your first row the same just for a minute. Just for a minute here. We're going to deal with that momentarily. So half of 0 is 0, half of 2 is 1, then half of 2 is 1. We're still not in row echelon form yet because the leading digit in the first row is a negative 2. We want that to be a positive 1. So this time you're going to take negative 1/2 of row 1, and then you should get a leading 1 in the first row. So negative 1/2 of negative 2 is positive 1. Negative 1/2 of negative 1 would be positive 1/2. And then negative 1/2 of negative 5 would be positive 5/2. And then you still have your second row of 0, 1, 1. Now we have this in row echelon form because the leading digit in each of these rows is 1. In the second row, this is telling you that y equals 1. So y equals 1, there you go. Now we're going to use back substitution, put that into the top equation, which is telling you that x plus 1/2 y is equal to 5/2. So go ahead, put that 1 in for y. So x plus 1/2 times 1 is just 1/2 would equal 5/2. You would get that x equals 4/2, which would be 2. So x equals 2. So the ordered pair that's the solution to this system is going to be 2, 1. That would be the ordered pair as the solution, would be 2, 1. And I have just 2 more, then we're done. All right, we have 9x minus 4y is equal to 2. Then we have negative 6x minus 16y is equal to negative 6. So there's your system of equations with 2 variables. Let's form an augmented matrix. So you'll have 2 rows since you have 2 equations. So to form the first row, take the coefficient of your x variable, which is 9, coefficient of the y variable, which is negative 4, then make your augmented line, and on the right side, put that 2. All right. Now, on the bottom one, the bottom row, the coefficient on the x variable is negative 6. The coefficient on the y variable is negative 16. And then you put that negative 6 to the right of the augmentation sign. Okay, so there's your augmented matrix. This is going to be fun because in the first row we don't have a 1. What can we do to make the first digit of the second row a 0? So if I take 2 times 9, that's 18. And then if I take 3 times negative 6, that's negative 18. And if I add them together, you'll have a 0 as the first number in the second row. So I'm going to take 2 times row 1 plus 3 times row 2. We'll form a new matrix from that. So for the time being, leave your top row alone of 9, negative 4, and 2. Now, take 2 times that 9. That's 18, plus 3 times negative 6. That's negative 18. 18 plus negative 18 is 0. Then take 2 times negative 4. Well, that turns into negative 8. Plus 3 times negative 16. That's negative 48. So negative 8 plus negative 48 is negative 56. Then take your 2 times your 2, which is 4, plus your 3 times negative 6, which is negative 18. 4 plus negative 18 is going to be negative 14. All right, well, it's great that we have a 0 in the second row as our first number, but this is still not in row echelon form yet because the leading digit's negative 56. It needs to be positive 1. So that means we need to take negative 1/56 of the second row, and we can form our new matrix. So for the time being, leave the first row alone. 9, negative 4, and 2. Now take negative 1/56 of row 2. That times 0 is still 0. Negative 1/56 of negative 56 is positive 1. Negative 1/56 of negative 14 is positive 1/4. Well, guess what? We're still not in row echelon form yet because the first digit in the first row is 9. It has to be 1. It's great that we have a leading 1 in the second row, but that's not enough. So go ahead, take 1/9 of the first row to put it into row echelon form. And then we'll form the new matrix here. 1/9 of row 1, so 1/9 of 9 is 1. 1/9 of negative 4 is negative 4/9. And then to the right, 1/9 of 2 is going to be 2/9. And then your second row stays intact. You'll have 0, 1, and 1/4. All right, we now have row echelon form since the leading digits in each row are 1. So this here is telling you that y equals 1/4. So that's great. Y equals 1/4. There's one value we need. Now, we're going to go ahead here. We're going to use back substitution, put this into the top equation, which is telling you that x minus 4/9 y is equal to 2/9. So we'll stick that 1/4 in for y. That's going to give you x minus 4/9 times 1/4 would equal 2/9. Well, this would actually end up turning into x minus 1/9 equals 2/9, which would mean that x equals 3/9, which really means that x equals 1/3. So the solution that would be your ordered pair is 1/3, 1/4. That is the ordered pair that is your solution. Would be 1/3, 1/4. And sometimes you'll have that. I got just one more problem, then we're done. All right. Let's say we have negative 12x plus 15y is going to be equal to 3. Then we have negative 7x minus 20y is equal to negative 4. This one's going to be hideous. So what I'm going to suggest here is, of course, let's put this into a matrix form. So the first row, coefficient on the x term is negative 12. Coefficient on the y term is positive 15. And then you have, of course, the 3 to the right of the augmented line. Second row, coefficient on the x term is negative 7. Coefficient on the y term is negative 20. And then we have the negative 4 to the right. Okay. Here's something you can do temporarily. Notice the top row. We're not going to convert the negative 12 into a 1 just yet. But notice negative 12, 15, and 3 all have a common factor of 3, do they not? Look for ways to make it easier on yourself. If you don't, you're literally going to be multiplying the first row by negative 7 and the second row by 12. Adding them together, you're going to get some really big numbers. Let's look for ways to make this easier. So if I divide the entire first row by 3, so in other words, I'm going to take 1/3 of row 1, you're going to have smaller numbers to multiply by in a minute. So 1/3 of negative 12 is negative 4, 1/3 of 15 is 5, and then 1/3 of 3 is 1. And our second row is still intact of negative 7, negative 20, and negative 4. Alright? Isn't this going to be much better to work with now? We just multiply the top row still by negative 7, but we only have to multiply the second row by 4 instead of 12. Much smaller numbers to work with. So first thing you want to do, make this first digit in the second row become 0. So we're going to do that by taking negative 7 times row 1 plus 4 times row 2. And let's see what the resulting matrix is. So leave the top row alone for a minute. You'll have negative 4, 5, and then 1 still. So now, negative 7 times negative 4, that's 28, plus 4 times negative 7, that's negative 28, so 28 minus 28 is 0, okay? Now take negative 7 times 5, what is that? That's negative 35, plus 4 times negative 20, that's negative 80. Negative 35 minus 80 is negative 115. Still hideous, but not quite as bad. Then go ahead and take negative 7 times 1. What is that? Well, that's going to be negative 7 plus 4 times negative 4 is what? Negative 16. So negative 7 minus 16 is negative 23. Well, what's great, we have a 0 in the second row for our first entry, but we need to make the leading digit a 1 instead of negative 115. So we're going to have to divide the second row by negative 115. So take negative 115ths times row 2. We should get another matrix then. So leave your top matrix alone for a minute. The negative 4, 5, and 1. Go ahead now, take negative 1/15 of the second row, so negative 115 times 0 is still 0. Negative 115 times, negative 1 over 115 times negative 115 is positive 1. Negative 115 times negative 23, that's actually going to be positive 1/5. That becomes 1/5. So now the leading digit in the second row is a 1. Well, we simply need the leading digit in the first row to be a positive 1. Then we have it in row echelon form. So let's go ahead and take negative 1/4 of row 1, which will turn the next matrix into negative 1/4 of negative 4 is positive 1. Negative 1/4 of 5, that's negative 5/4. And then negative 1/4 of 1 is negative 1/4. And then you have your 0, 1, and 1/5. So now you have a matrix in row echelon form, since both of your leading digits in both rows are 1s. And this here is telling you that y equals 1/5. So we got the y solution to be 1/5. Now use your back substitution and put that into the top equation. This will literally turn into x minus 5/4 y is equal to negative 1/4. So go ahead and put in 1/5 for y. That's going to give you x minus 5/4 times your 1/5 would be equal to negative 1/4. Well, negative 5/4 times 1/5 would end up being x minus 1/4 equals negative 1/4, which would give you x equals 0. X would become 0. So the ordered pair that's your solution would be 0, 1/5. So that's the ordered pair that's a solution to this system, is going to be 0 and 1/5. So next lesson, we're actually going to do row echelon form, but with 3 variable systems of equations. So we'll do 3 by 3 matrices and show you row echelon form for a 3 by 3 matrix. So I do hope everyone has a great night. Take care.